Hello to this webinar on the terms and the concepts behind AI chatbots. My name is Tilman Scheel. I'll come to that in a bit. And I will explain you a little bit what we do with chatbots and how to speak about it. Also excuse myself for this rather strong statement at the beginning of this presentation. Of course, there's a bit of irony in there, but there's also a serious background, and also I'll come to that in the next couple of slides. So yes, welcome, especially also those who have visited a previous webinar. There is some, and I hope you'll learn, you'll be entertained, and you'll have a bit of fun. The great part about this webinar is that it is attended by a great many people from a great many countries. Somehow we call it by now the registration porn. We look at all the country endings in the emails that you send us, and there are so many that we have never seen. It's great. It reminds me a little bit of my old backpacking days, So give me an excuse and I'll visit you wherever you are, from Abu Dhabi via Indonesia to the Porteños in Buenos Aires. And we also discovered that it makes a great difference in which language we offer the webinar. So we'll also offer the webinar in French and in Spanish. I just have to unpack my language skills a little bit, but it's possible. So if you're English or if you're a French or Spanish speaker, let me know, because we'll then, if you would support us in distributing news about this webinar in your network, that would be very helpful. Also, what is interesting to note is that even though we were the first ones to start a chatbot for libraries, our first library and our main client is the Public Library of Berlin, or public libraries, with 430,000 users and 4 million media units, but it's a public library. Interestingly, the registrations for this webinar primarily come from university libraries and research institutes, which actually makes us happy. But I also think that there's an explanation to that. And we're also happy about the few museums who attend, because I think museums are also a very, very interesting target group for the chatbots. So why did universities attend? We talked to some, but we also have a very specific guess about it. So, and this is actually the reason why I put this rather placative slide in the beginning of the presentation. If you ask students, if you ask anybody below the age of 25, I think Google is dying. So here is a non-representative study. It's actually, friends of friends and nephews and my godchild. But actually, there are a number of students from various fields. And some of them even said, I don't use Google anymore, I only use ChatGPT. It depends a bit on the field. So the natural sciences tend to use ChatGPT stronger, whereas social sciences, law, use it a bit less. My guess is that actually the training knowledge of ChatGPT is weaker on language-specific topics. But in science, where it's all the same language around the globe, students primarily use already ChatGPT before Google. And of course, this creates a behavior, this creates a level of expectation that I think university libraries feel first, but public libraries will feel that too, in not too long a time. I've added some quotes. Actually, I think the main reason is you get an answer straight away. You don't have to browse through results. And the second thing is you can actually talk to it, which Google does not do. So I think I'm convinced that actually accessing media collections, book collections through chat and getting an answer rather than a list that you have to then again search in is the future of accessing information simply. So why am I talking about this? I'm a lawyer and art historian by let's say, by education. I moved into IT. This is how life goes. In 2004 already, with operating a video on demand platform for the film industry and for libraries. So we also run AFA Library, which is a video on demand platform for libraries. This is how we came to the libraries when we developed our chatbot. And also, of course, I'm the founder of About Something, abbreviated to Ask, which is the first chatbot for public libraries, to our knowledge, still around the world, launched by the FEP, so the union of the more than 80 libraries in Berlin. So, and the one thing that is important to us, we are already live. So I'll show you later in the presentation. So we are on it. So we don't have any plan. It's not some concept that we have or some idea that we have. We are working on this every day. We are getting user feedback every day. We are improving based on user feedback every day. And I think this gives us quite some knowledge on how these systems behave, what there needs to be done to improve them, and also what the future could look like. But actually, so this is, but of course we didn't stop with Berlin. So we already have a test system running for all libraries of Flanders. Sorry, my Flemish is limited. And also we have integrated with a number of library management systems, so ELS, Axial, big international one, Aztec, the one that runs the libraries of Berlin, Daytronic, a German one that has 1,000 libraries under its wings, and Koha soon. So, and of course, it's much easier to integrate the bot once we are connected to a library management system or ILS, I think in English, because we receive the data through them, and so the library doesn't really have to do anything about it. So, first term of this webinar, expectation management, most important term in AI. The funny thing is that AI is kind of, if you talk to the ones, it's the doom of mankind. If you talk to the others, it's the solution to all problems. It's, of course, somewhere in between, like everything. And of course, AI has limitations. 2 or 3 limitations I'll mention in this webinar. And you have to kind of, one being, for example, that AI only knows what it has been taught. So, so these expectations have to be managed. Funnily enough, we see an improvement in user behavior already in the last couple of months. So also search with Google had to be learned when Google came around. Now the usage of ChatGPT and other bots has to be learned. And we can see in our interaction with the users that the expectations in using such a bot more and more match what the bot actually can do. So this is kind of a general shift in society. Of course, also, this is a learning from using a bot like ours in other contexts. So we can see that the expectations more and more match the reality of the thing. The second, my personal expectation management is that I'm not a developer, I'm not a scientist, I don't actively work in machine learning or anything like it. I'm just a regular guy who works with AI. And when we started off, I had to teach all of this to myself because, of course, there are some courses on explaining how to develop internet AI, but there are very few courses who teach you everyday stuff that you need to work with it. And this is kind of an experience I make every day when talking to libraries or any other. We talk, of course, a lot with administration because it's also important for public administration. And with museums, and the terminology is not yet even in the heads of the people. Fair enough, and I had to teach all this to myself. And in order to kind of make conversations about AI easier in the future, we kind of designed this webinar. Second part of the expectation management, very important. Today, this webinar will be about some basics like expectation management, and also with working with the metadata. But when I wrote this webinar, I realized that it's way too much for 1 hour to do everything. So the whole conversation part, prompting, for example, will be pushed back to another webinar, which of course you are all invited to. So if you like this one, there will be a survey at the end of the webinar, which, if you like what we show you today, I would very much ask you to fill in. If you do that, we also have the context and can invite you to this part 2 also. So the second kind of intro into terminology. In talking with about bots all the time, we realized that even though it's always only one bot, or the one bot that we provide, there are certain use cases that are in many ways different to each other, and it helps to separate these use cases from another to be clear about what we are talking about. So to give you an understanding of what I mean, we started with a recommendation bot. So the original idea of the Berlin libraries was that because search is just, I learned that, for example, advanced search is only used by 0.5% of all its users. All the others just use the Google kind of fill my thoughts in thing. And so the idea of the Berlin libraries was that, of course, user behavior changes. We've seen that. But also to provide another way of accessing its vast collection, and also provide, let's say, other media that is not found by search. Because, as you know, with search, you kind of have to have an idea of what you search. It doesn't replicate, for example, this feeling that you're standing in front of a big wall of books and let yourself be inspired. For this conversation, it works much better. So this was the original thought of the Berlin libraries, but very soon, so that was the recommendation. So very soon we learned that actually there are many other questions, like, what are the opening hours? Where's the cafeteria? Where's the bathroom? What happens if I have to pay money because I didn't give back my books in time? So so we added that very quickly, because that is many of the questions that we receive. The difference, though, is that with a recommendation bot, we were only working with Mark 21 data coming from the library management system. With service questions, you have to be up to date. You have to be kind of at least once a day, or even quicker. You have to include opening hours because they might change because of a strike, whatever. So we actually scrape websites for that, because there it has to be up to date too. And if it's not on the website, of course, it cannot be on the bot. So the data source is different. And also the demand on being up to date with things. Next thing, and this is what we're building right now, is a knowledge bot. Here, the knowledge bot actually is also very interesting for public administration, because the idea of the knowledge bot is that inside an organization, there is a lot of knowledge that is distributed over many different knowledge sources, like wiki and PDF and paper even. Especially the bigger the institution, the more the older the institution, the more difficult it becomes to keep track of all these of all this knowledge that is gathered inside the institution. So, for example, has there been a press release on this? Is there a specific procedure on that? If a user has lost his library card, what can I do? Or in an administration, what is the status of or what are our conditions for hiring people? So all this, of course, can actually be done with a bot, who you can actually ask, and who potentially knows everything that you have fed to it. And here, of course, again, the challenges are quite different, because you have an even more diverse set of data. It can come from a wiki, it can come from a PDF. Paper doesn't really help, because we can not process it, but sometimes there's even that. And the second challenge in this type of bot, or in this, let's say, it's variation of the bot, is that especially because it's internal knowledge, there's a higher security and transparency standard. So it comes with a requirement of hosting a large language model, a model locally. So, for example, a Llama model on a server that is inside the institution. So again, even though it's the same bot that can answer questions, and it has a different setup and a different data requirements. The last one, and I think this is the most interesting bot variation for universities or for museums is the media bot. So in the recommendation bot, we talk about literature. So we have the summaries of the books, and then based on these summaries, you can lead a conversation with the bot. In the media bot, you can talk with the books or with the films, even if you have, for example, the subtitles themselves. You can say, for example, if you're in a university, give me all the studies on this particular topic and tell me what these studies say about. So that would be one. Or you can say, you know, where was Schopenhauer angry with Hegel if you're in philosophy? And so actually, if you, for example, ask where's Schopenhauer angry with Hegel, you get quite a number of responses because he was angry with Hegel all the time. So if you get an answer there, you want to have the footnotes. So from which parts of the works of Schopenhauer was the answer of the bot generated? So you need the footnotes in the answer of the bot. So these are some of the challenges of what we call the media bot. And then, of course, you have the technical challenges that come with the media bot, because it creates, of course, lots of context. So because, I mean, the body of work that you have to communicate with is much larger if you have the full book than if you have just the summary of the book, which translates into higher costs, because all of that, I'll come to that, is turned into tokens. And there are challenges that have nothing to do with AI at all. For example, the whole question around rights. So if a publisher has the rights to a book, he's not necessarily happy if you don't read the book, but just ask the AI what's inside the book. For me, this is the most exciting task, but it's by far also my most challenging task. But as I will mention multiple times in this webinar, the only way to actually find out about it and make it work is to actually do it. So we're preparing that as well. All right, some more technical basic things. The LLM. So I've done an earlier webinar where I explain how a large language model works in a bit more detail. So I'll kind of skip over it. The only thing I want to mention about an LLM is it's kind of an artificial neural network that has a vast memory, pretty much the memory of everything that you have fed to it. I mean, the large language models of today are fed with an incredible amount of data. So, you know, we talk about billions and billions of parameters. There are some rumors in the net that actually the most current ChatGPT model was trained on a trillion set of parameters. So it's just massive. It's huge. Still, it doesn't know anything, and especially it doesn't know anything about your particular data. So it has to be taught like any other human, and what it hasn't been taught will not be able to enter into any communication. And then it's only human. You know, there's this whole topic of hallucination, which is not part of this webinar. It will be then part of part 2 that I couldn't fit into this one. But frankly, in our experience in the last couple of months with users, hallucination was never ever a topic, ever. It's always a topic with librarians. It's always a topic with politicians. But for it's also quite logical, because for a recommendation bot, if there's some error, nobody really cares. You know, sometimes it might be even interesting. It hallucinates something that I didn't expect. Of course, the expectation is a bit different if you have to be precise. For example, and you know, if you use it for scientific work. But there are technologies to cater to that too. But again, also I'll get into a bit of the technology behind later, and you know, it's only human. Remember that if you use ChatGPT, which is I think the most popular software of the moment in the world, they still say please control the result of this conversation because it might be wrong. A very important use case of expectation management. Another thing, next point, that is always confused in communication with me and also with clients that we talk to. They say, "Oh, how do you train your LLM?" The answer is we don't train an LLM. Training an LLM means you create the body of knowledge of the large language model of this AI. And this is a huge work. This is what the Googles and Metas and OpenAIs of this world do. It's way beyond the use cases that we work with. It's very expensive. You need lots of manpower and good investors who have a long patience. We have none of that. So training an LLM is just not is off the books. Fine-tuning an LLM, so taking an existing LLM and teaching it the knowledge of your institution, of your company, it's actually doable. It's many companies do that. Some institutions try that. We have had this case as well. It's a bit more expensive, but it's doable. It's especially, of course, helpful if you want to host your own language model. But for our use case, and when we deal with large media collections, where actually the data set changes every day because books drop out, new books are bought, films fall out of license, new films are being acquired. The problem with fine tuning is that it's hard to unlearn. You can teach an LLM a model a great many things, but you cannot unteach it, or it's very hard. So if you have a set of data that varies quickly, fine tuning is pretty much not a good idea. Or not. So what we all do, we the community of people who work with AI for their various use cases, is we do RAG. So if there's a thing that you have not yet heard and that you learned during this webinar, this is the most important one. It's called retrieval augmented generation. So actually, I don't know what augmented generation means, but I do know what retrieval means, because it's basically retrieve information from your source and feeding it to the bot. And how this works, I'll come to that now. One little remark at the about open source, because it's also something that we get asked quite regularly. It's like, why don't we host our own LLM? Isn't that much better if we have it ourselves? There's this tendency, especially in institutions, to kind of take everything in that they need. The thing is, I like it, of course, because I like the idea of open source. I like the ideology behind it. I like the people who work in it, which is also important. But for this particular use case, it didn't work. And I made a little game about it. So what are the different parameters to make this decision, whether we use ChatGPT like we do now, or whether we make use of an open source model? As you can see in the end, ChatGPT won. And I'll tell you why. So the quality of the conversations for the moment is, I think, better with proprietary models. I do believe, however, that this will change in the very near future. So I think, give or take 1-2 years, the quality of the conversations with the big models will pretty much be the same, depending maybe on the languages that are being utilized. But the field will be leveled very soon. The thing is, what is always forgotten, open source means, the software is free. Yes, the software is free. What is not free is the installation on a software, on a server. It's the maintenance, is patching up the security updates, is looking out for the output control. So the maintenance of open software is just way more expensive than just, hooking up with an API, with an interface with ChatGPT. And for us, this is just too costly. So maintenance and costs are better with proprietary models, even though you don't have to pay tokens to them, to your own local LLM. It's still way more expensive to do that. Of course, if your requirement is on transparency, or if you have the need to protect specific data, or if you need to certify a solution because you're a public institutions, for example, one of the library management systems that we have integrated with also has an integration with the German Parliament or with the German Ministry of Finance. Especially with the Ministry of Finance, I'm quite sure that there's some information that the general public is not supposed to see. In this case, of course, it's much better to have an open source system adapted to your needs and hosted locally. But for the library use case, it doesn't really make any sense. And the last thing, and which is easily forgotten, but is very important, especially if you have copyrighted material like libraries do. Next example. So I asked Midjourney, when I wrote this webinar, I wanted to show that with open source, so with hosting your own LLM, comes great power because you can tell it what you want, but of course great responsibility because you have to check for bias and for copyright. And I created an image in Midjourney, and the Spider-Man came out, which is probably what will happen with a regular open source model. And you get the response of ChatGPT where it says, it goes against our content policy, which actually should be the answer, even though in this particular case it was a bit annoying for me because I didn't get my picture. But actually, by now, ChatGPT is really good in checking copyright infringements. And if you don't want to have troubles with your bot, this lets you sleep safe and sound. I don't want to get mail by some kind of content owner who sees his content on our platform without being paid for that. Last basic thing is probability. Also a concept that is very important to understand when you work with large language models. So large language models are a probability machine. This is how it works, very briefly. So you have a sentence, the cat chases, and then there's a probability that this answer, or you can, and of course you can extrapolate that to any other query, or way more complicated queries as well. So there's a certain probability that the cat chases a dog. The highest probability is that it chases a mouse, less a squirrel, and even less is a pink elephant. So all these, the important part of that is most probably, the cat will chase the LLM will finish the sentence. The cat chases with the mouse, but there's a small but existing possibility that it also chases a pink elephant. This is how probability works. It's improbable, but it can happen. So and because it is a probability machine, precision is kind of not built into the system of AI. It kind of has to be added later if you want to work with it. Let's say as a consultant for financial services, where the requirements on accuracy are a bit higher. In recommendation engines, it's not a problem. But as I said, it's a probability engine, and with probability comes insecurity, so it's mostly right, but not always. The second aspect is that the answers will be quite average, because of course the most average answers are the most probable. And sometimes, though, it doesn't work at all. And this image on the right is a very good example. This image took me like, 20 tries, and I still didn't get what I want because I wanted the cat to chase the elephant. So obviously the probability is even less than 1%, and there's not a single instance in the training data of the models where actually the cat is behind the elephant chasing it. And if it's not, so probably there's not a single image in the training data that does that. And because of that, neither with Dolly, nor with Midjourney, nor with Adobe Firefly, I was able to place the cat behind the elephant, because that's simply not how things are done. So all artists, be secure in your artist world, because the real originality is not yet what LLMs do. So working with metadata. Now we go into the real thing. So these were just the basics, and now we talk about our setup and how it works and what terminology we use to describe how it works. So I'll start with an example of a great artist that I really love, Rebecca Horn, who passed away a couple of weeks ago, I think. And I asked, and I used this prompt: are there books or films that have inspired Rebecca Horn, to show you one of the issues of the current state of chatbots. Also, I'll hint at some of the solutions. This is actually the problem. So on the left, you have ChatGPT with its own intrinsic data, not hooked up to any library system. So this is On the left, you have the answer to the question, are there books or films that have inspired Rebecca Horn? The answer is great. So yeah, Kafka and Arnaud and surrealism are all really, if you see this kind of machine, a butterfly, surrealism is just great. Metamorphosis is great. It's a great answer. On the right-hand side, you see we're totally transparent. You see the current answer you'll get from the chatbot of the Berlin libraries. So it does many things well. We have very good user feedback, and it gets better every day, which is great. But some things, and especially questions like recommend me something in the style of, give me something that has inspired them. These questions, the bot is not really good at answering for now, and it'll change next week, and I'll show you why. But this is kind of built into the system, and if you understand why that is, you will have understood the whole much of the concepts and the terminology behind what's going on in RAG systems. So I'll show you how that happened and what to do about it. So this is a RAG workflow. Basically, the black box is about how to get the data in, so the retrieval part of RAG. And the blue box is how to then make conversations with the data that you have provided to your system. As I said in the beginning, this webinar will be about only the black box, so how to get the data in and what to do with it. How the conversations are made and how they're made well will be then part of the second part of this workshop. And as I said, and we will of course publish it through the usual networks. But if you want to be sure that you're invited directly, just fill in the 5 questions of our survey at the end. Both works. So we'll focus on the ingestion part. So of course, the institutions that we work together with are quite different. So we have with public libraries is already online. There's a scientific library that we collaborate with in developing a solution. We would love to work with museums, also for personal reasons. I just love art. And then there, the third parties that we usually use to integrate. The library management systems, the website, if it's a service, a bot. See, good usage of the terminology. Of course, it can be PD, it can be any other third-party source. The input data then is Mark 21, especially in the case of the recommendation bot. User data, because of we want to be able to, if data protection allows, we are in Germany. If data protection allows, we want to have good user experience, and this, of course, is great if you have the borrowing history of a user, for example, or previous research questions that you can then build up upon. It comes in the form of HTML if we scrap a website, a PDF. So this is the API, the kind of data that we receive. The more formal, actually, the more how to say, if it actually it's not true, so I forget my last part. So we turn this data then into tokens and chunks. So these are 2 words I want to elaborate a little bit upon. So what are tokens? So you have a ChatGPT definition. Basically, a token is turning a word into units of numbers. A token is not a word. A token is just a unit of signs. So, for example, we're in Germany. We have this beautiful tradition of creating really long words by putting nouns together. Donaudampfschifffahrtskapitänskajütentüreshaken would be one of them. So it's a very long word. And this word probably has like 7 or 8 tokens. But if you take a simple word like door, that would be like 1 token. And so the general rule of thumb is that you have a token is a word plus 30%, depending on the language. Some languages are shorter. If I remember Indonesian well, Indonesian has very short words. Japanese as well. So there the percentages might change, but in general you're safe with this bet. Why is that important? Because for now, at least, tokens are the currency of AI. So when we run the chatbot, the usage of the chatbot is paid to OpenAI based on the number of tokens we consume. So the more tokens you consume, the more money you pay. So basically, the more words you use in your chats, the more money you pay. By the way, this is one of the reasons the current conversations are limited to I think 8 question and answer pairs, because the more the people talk, the more expensive it becomes. Also, it's influencing the amount of context that we use to create the best of answers. So the context is the information around an answer. So all of these configurations are kind of made in order to balance user experience with cost. So in this sense, token is kind of a very important part of the discussion around AI. Next thing is chunks. Actually, the way we work with the data is breaking up longer text into chunks. I'll show you briefly what chunks are live. For this, I'm going to stop the bot. I'm going to go here and I'm going to share again. This time, I'm showing you this. I hope you can see my screen. If you don't, let me know in the chat, but I think you can. So this is actually the backend, the live backend of the FAB libraries. It's a Django backend. It's not made for usage. So excuse if it looks very technical. But if you go here, for example, so this is all the data of the Berlin libraries turned into chunks. So a chunk is a unit. This actually, I think the maximum size is this. And then in this unit, you can see the ISBN, for example. You can see when it was published. And at the end, you can actually see a link which forwards the user, once he has received information based on this chunk, to the particular work in question. So the user can start the borrowing of this thing. So these are chunks. Basically, if you now I stop that, we'll come to this website back again later. Let me just, where is the bot? So I'll give you my screen back again. I always return to this front page. I'm just not smart enough to find out how I immediately return to my last place. But here I am. So this is chunks. They're the smallest units of text that the text is broken into. It's especially important if you talk about the media bot, because there the whole PDFs, I don't know, 500 pages have to be broken down into chunks automatically, and the chunking process is already influencing the quality of the answers that you get. So this is just my live presentation safeguards. So what happens with these chunks? So the chunks arrive at the back end. You just have seen the back end. From the back end, they're sent through an interface to OpenAI. OpenAI then creates a vector. And the vector is then sent back to us and stored in our vector database. So what happens is that the actual search for a good match to the user's question is happening in our database based on the similarity search. So what is all that? A vector, an embedding, a similarity search. We'll come to that now. So an embedding vector is a numerical representation of actually the text that you provide. Numerical, it's a big number. So your text is turned into a very big number in multi dimensions. Because the number is so big, or why is this such a big number needed? Because the number is because actually what this number can do, as opposed to for traditional keyword search, is it can also store context around the particular word in question. So that allows the bot to understand, for example, also to answer a question like "I'm bored," and then kind of, okay, what's bored, and then we'll ask back on that. So all these context and sense issues can be handled with this vector. So this is a vector and how it works. So you have very big numbers. So this is kind of a three-dimensional space. I think it has, I don't know how many dimensions it has. I think it's 2000 now. So it's a very complicated space that only mathematicians understand. I certainly don't. But what I do understand, and I think what's needed to be understood, is that every vector representing your data is stored in a particular place in this huge multidimensional vector space. And all the other vectors who, and remember, store all the context around that particular piece of information are also stored in this huge vector space. And if you make a query that is, a question, which will also be turned into a vector, and then the system checks which vector is most similar to the vector of the question that I have just proposed. And based on the similarity, a number of vectors are chosen, given back to the LLM, and out of these resulting vectors, the answer will be generated. So the short version is a vector search is a similarity search, just on a very, very high, let's say, abstraction level with a lot of information attached to a vector, but it still is a similarity search. The answer for an answer will be answered. A question will be answered by something that is similar to the question. That is the very simple explanation to that. And this vector will then be used in this RAG workflow. So basically, the RAG workflow is we get the data, we turn it. So on the left, we have the data. We chop it up into chunks. We turn it into the vector we have just discussed. We put the vector in the database. And then if a user comes, we'll search for the matching vectors. We'll put it to the chatbot who makes a natural language response out of that. And then the chatbot will use this result to talk with the user. So this is the workflow. As I said, the blue part, the chat really will be part of the next webinar. But so you have here you have an overview of how a simplified overview of how that actually works. Okay, now the problems. Part of our expectation management, but of course also part of us showing you the experiences that we have made and that we continue to make every day. So, and if you remember the chat that I've shown you a couple of slides before, the problem with similarity search is that what is most similar to, let's say, the 7th edition of, or the 110th edition of Shakespeare's works in a library? The answer is the most similar thing to the 110th edition is the 109th edition. So if you ask a bot, can you? I really like Shakespeare. Can you recommend me something similar to Shakespeare? And then the bots, basically translates that into Shakespeare most current edition, and answers, oh well, the most similar thing to the most current edition is actually the previous edition, and then the bot will recommend you again the same work, just in a different edition, or works by the same author, which also happens if there are not so many editions. But this is not what you want. If you say, I want a book that is similar to Harry Potter, you don't really want another. I don't know. Don't want to have another Harry Potter work. You don't necessarily want a work of J.K. Rowling neither, because that intelligence is every reader is looks for the same works of the same author. What you want is probably some kind of fantasy with children appeal. So this is what you actually want. And in order to teach the model to do that, you have to enhance the solution that basically is you have to enhance this RAG workflow that I've just shown. So how do you do that? You enhance the solution first by checking the configuration. Sometimes it's just okay to just enhance the number of vectors, of dimensions to the vector, so the vector can even be more can be even more complex than the 2000 dimensions that you have. This is usually a configuration of the vector database that you're using, so that's not too difficult. Improving the data quality, big topic. we also have with libraries, for example, MAG21 is structured data. AI can only use, or is best with natural language. So actually, when importing data from a library, we turn structured data into natural language. And of course, this is a process that can be improved, that can be worked upon. Also, duplicates are not so super funny. So this is how you can improve data quality. The most important thing, and I'll show you that in a minute, is updating the LLM, because of course the way the LLM analyzes the vector space and also chooses the answers is part of the equation, and the more current the models are, the better they solve the similarity question issue. Another thing is how to create the vectors. So they're so-called embedding models. These are the models that create this long series of numbers out of your content. Especially with languages, with languages that are not English, they're models who are doing the job better than others. So we are very happy, by the way, to collaborate with people from countries that are not natively English speakers or German speakers or any other of the let's say more popular languages of the world. So we'd be very happy to collaborate with people from Africa and or Indonesia, anyone who doesn't speak this boring English language, to try out what the best solutions are for their mother tongue. So embedding model is one big way to improve things. Improve the chunking process, that's very technical. I leave it aside. Increase the vector dimensions, I've said already. Increase context. So basically, the more vectors you provide inside an answer, the higher probability is that one of these vectors might fit the user well. Again, we discussed the cost of tokens. That costs more money. So as always, with pretty much any technical solution, there's a trade-off between different goals. Keeping costs under control, providing a good, the best possible answer is a trade-off. As you can see with ChatGPT, because of course they make the trade-off with costs. If you take the most powerful model, that'll be way more expensive than the cheapest. The current model with the FEP is 3.5, which is ancient. But we have to, and this is the last point in this upper list, we also realized and made the experience that the prompts, so the commands you give to the bot on how to do an answer, have to be adapted not only from different models, so from Gemini to ChatGPT, but also from different versions of the model inside a model family. So we're in the last bits of testing of updating the model, because we had to adjust the prompts quite a bit. How to work with prompts will then be part of the conversational part of this workshop and the second part. So the second big topic around improving conversations is introducing technologies. As you might read in the press, there's always this big talk, Microsoft buys an atomic power plant because they need so much electricity and training their new models. Actually, for our use case, the models are, the current models are almost smart enough. They're just new technologies who help to improve particular issues with the conversation, like the similarity search issue, or also make use, especially with libraries, of structured data that they have accumulated over sometimes centuries. And I'll briefly mention to you these kind of more complex concepts here. See, good, a reminder. I wanted to show you how how to improve a little bit, and how this improvement worked for one of the systems that is already online. So I'm going back to the live section of this presentation, and I'm showing you my browser again. My blood level rises always a little bit when it becomes live, because you never really know, as anybody knows who makes a presentation. So I hope you see my screen now. So this were the chunking part. So this is actually, again, the chatbot backend that I showed you. I made a Tillman test. So this is actually, here you see a prompt window. So this is where so this is all live, by the way. And this is where we do the prompts. We do kind of the commands on how the chat behave. So one of the interesting things, you can even change the language immediately. So I'll say begin the conversation in Arabic, for example. I have no clue about Arabic. I hope if there are Arabic speakers around, I will not completely make myself ridiculous. So begin the conversation in Arabic, that's fine. And here you see the model GPT-4o. So which is the biggest, let's say, model for this particular use case. There is one newer one, but this is mostly for mathematics and for coding, not really for our use case. So you have a newer model. You have and let's see what this. You have actually slightly adapted prompts. And let's see what this change in the setup that I've just discussed in the previous slide does. So I'll show this model here in a testing website. This is how we do our tests, by the way. We just change little things in prompting and models, and then we see what effect that has. As you can see on the left side, there are a number of testers around to work on that. And I'll ask the same question that I've showed you previously here. So what are the books and the films which have inspired Rebecca Horn? Yes, give me the details. So actually very good. It's part of our let's say prompting that in the moment the bot wants to be secure about a result, he should ask back again. And here this result looks much better than the result we had before in the version of the bot that used still 3.5. And so this is how we do it. We change a bit on the prompting side. We change a bit on the with the models. We use and then we check it through these setups, and then we see whether the results are better than before. All right, let me that went kind of well. Let me check with so this is, as I said, this is all live. This is how the actual system is working. I'll go back to the presentation. Bear with me, it will not take more than 5 more minutes. Oops, that was the wrong one. I wanted to go back to the presentation. Where's my Zoom? Oh, here. All right. Okay. So we're virtual volume. Okay. So this is where we stopped. So we go back to this. Okay, we had a look at this. So and just a brief way of also technologies. So actually these are technologies we're assessing in the background. If there's any research institution who wants to work together with us and wants also to receive feedback by actual users, we're happy to join projects. So two technologies that will greatly enhance conversations, especially in the MediaBot section when you talk about the whole bodies of art, is hybrid search, which basically combines classical keyword search with vector search. The way it works is you have a keyword search with a set of results. You have a vector search with a set of results, and where the results match, and the results that match become a higher ranking. So actually, that in that way, you can filter out stuff that is actually the best match in both technologies. Very simply put. The other even more interesting thing is for us is GraphRag, or it's actually knowledge graphs that represent the relations between topics. So for example, you have Rebecca Horn, and she's related very closely to Kafka and Metamorphosis. And Kafka is, of course, if you know his short stories, also very closely related to Metamorphosis. And not so much with nature, but Rebecca Horn is. And so already in looking at this graph, which actually was produced by ChatGPT, you can see that there are relations between between topics that can actually be used to enhance the answers as well, because then actually if you, for example, talk like abstract terms like inspiration, you can relate to this in your answer and come to a better understanding of what the user wants. So, for example, if you now if you compare vector search, which is data points that overlap because they're similar, and knowledge graphs are actually the relations between the data points and who is related to what. So this is actually apart from training your own model or using a new model or creating another model, are technologies that are very promising in developing chatbot technology further. Actually, no, I want to stay here a little bit because one thing, and this is an invitation to everybody in this webinar, this knowledge is just fresh, let's say fresh from the kitchen. And the people who know about that are either the scientists who develop it or the people who are actually introducing these technologies to their workflows. And the only way in keeping up with this knowledge is to talk with people. We are happy to be in Berlin because there's a huge community of AI enthusiasts. For some reason, many Indians in Berlin in AI. So we all learn from each other simply by communicating and by we even have an AI dinner. So communication in this quickly evolving field is really, really important. It's almost as important as having fun with it. As you all know, the best way of learning things is playing. So I invite you all to actually apply AI and learn about it by actually doing something with it. I think if the idea is to visit a webinar like this one, and then and after that you've heard about it and you understand it, no, you have to actually do it. And then you learn about the possibilities and the limitations. Going to the next webinar. So there I'll talk to multimodal LLMs. We didn't talk at all about how to process images and for example tables, which is also super important if you talk with PDFs in science, if you talk with publication in science. Prompting is the most important thing you can do when you want to do anything with AI, because this is how you tell the AI what to do. And of course, we have a lot of information to share there too. Metrics. It's very, very, very interesting that there's no objective metrics on the quality of any conversation. Of course, there's right or wrong. A wrong answer is a wrong answer. But beyond that, what makes a good conversation is pretty much based on the human judgment of the people who test. So if you belong to the doomers and think that AI is destroying the world, in this very simple world of chatbots without humans who actually tell the chatbot what's good and what's bad, nothing works at all. So one of these limitations. Hallucinations, I talked about that already, doesn't make any impact on our everyday life, but still you have to deal with it, especially if precision is a requirement. Language management. As I said, I'm really interested in languages. I'm really interested in having this bot in as many languages as possible. My mother-in-law uses this bot in Farsi, so using the Arabic alphabet works quite well in the setup that she's using. So it's not really a problem, but of course there are many pitfalls. And the pitfalls only come through testing. And of course, the testing you only do when something has a use case, is live. So testing and testing and testing, and how to take feedback and turn it into better testing is also one of the topics of the next webinar. That's it. So I made it in 1 hour, so very little. I mean, you can stay around. I'll stay for Q&A. A little bit, but so and I'm also sorry if I ran too quickly through it or talked too fast. Let me know. If you want a certificate of participation, which for some is important, just email us. We'll get you one. And then please fill in the 5 questions of the survey at the end. It helps us also getting better. It's the feedback that we need to test on how to do better webinars. So this is basically it. Here's my contacts. You can happily join me on LinkedIn. We have the previous webinars on our website. There's also a forum that I should probably work more onto, or let the others more contribute to that, but we'll get there. Okay, so there. Actually, what I always the questions. I'll start. Thank you is always good. Excellent is also good. The screen is not shared. I hope that is. I tried to fit quite a lot of. Yes, that is actually a very good point. 1950s editions and publications. So that is part of the promptings. So, for example, for travel guides, we specifically prompted the bot to always only suggest the most recent editions. Actually, how to do that with other works is still open. I mean, the bot doesn't know by nature that human beings tend to tend to prefer the things that are more current, and in some use cases even actually they don't. If you're a historian. So how to mitigate that is really a question. It's a prompting thing. So we have to tell the bot what to do, but we have to tell it for every use case that a person asks to the bot. And with travel guides, it's obvious that you want the most recent edition. With other books, it isn't. So, for example, one way to mitigate that, but I'm kind of also already entering the next webinar, is that you tell the bot to ask questions back again before giving an answer, like, do you want more recent stuff or do you want more old stuff? But again, this is part of the experiences that we make every day and that have to be adapted. So, and okay, that was one. All right. So you have 30 more seconds to go to ask a question. And then I hope that you had fun, which is the most important thing in AI. It's actually why we did it, because it helps and it's also very, very interesting. I can only recommend working with it. All right, thank you very much. I'll stop sharing my screen. I'll give you a goodbye and hope to see you soon at the next webinar. And by the way, if there's stuff that you really want to know and that you want to be addressed in the webinar, again, working with AI is all about communication. So tell me. Goodbye.